Deep beneath the Mediterranean Sea, an underwater volcano is getting ready to erupt. It is a ticking time bomb that could cause global chaos. So what are scientists doing to try to predict when it will blow? What would happen if it did blow? And is there anything we can do to stop it? Let's find out. In today's episode of SCI Show News, more than 26,000 years ago, Mount Vesuvius erupted in Italy, burying the nearby city of Pompeii in ash. But it wasn't the only place that saw volcanic activity that day. About 90 kilometers away, another volcano erupted under the sea near the island of Santorini, now called Thera. This one blew up so violently that it may have affected climate patterns around the world for years afterwards. But the real doozy happened about 300 kilometers south of Athens, Greece. The underwater volcano had been building pressure for a long time, and when it finally erupted, it unleashed about 280 cubic kilometers of material, equivalent to about 110 million Olympic-sized swimming pools. That eruption was about 200 times more powerful than the one at Pompeii. And while archaeologists have been able to study the remains of that ancient city, the underwater volcano has remained largely mysterious until recently. Scientists have been working to map and explore the caldera, which is the wide bowl-shaped depression that forms after a massive volcanic eruption. Their goal is to understand what happened there, and to see if they can learn how to predict future eruptions, not just in Greece but all over the world. Now that caldera is home to two islands, Pelia and Nea Kameni, and while the big eruption happened thousands of years ago, scientists think it might be due for another one. After all, it's part of the infamous and very active volcanic region known as the Circum-Mediterranean Belt. This belt includes Vesuvius, Santorini, and more than 500 other volcanoes that stretch from the southern tip of the Mediterranean to the coast of Chile. Some of these volcanoes, like Mount Vesuvius, are notorious for their destructive power, but others like El Hierro off the coast of Spain and Stromboli in Italy have been rumbling with unrest in recent years. The question is, which ones might blow and when? Well, the good news is that scientists are developing some really great tools to monitor volcanoes. Satellites, for instance, can track small changes in the shape of a volcano or variations in temperature, and they don't even need to be orbiting Earth to do this. NASA's unmanned Mars InSight lander has even detected small earthquakes or Marsquakes happening on the red planet. Some of these quakes were likely caused by the shifting of tectonic plates, while others might have been triggered by flowing magma. Now, we don't have InSight on Mars, but we do have similar technology on Earth. The European Space Agency's ESA trio of satellites called the Sentinels are orbiting our planet and collecting tons of data every day, and one of their missions is to watch over volcanoes in the Mediterranean. This particular project is a collaboration between ESA and the Hawaii-based Global Change Institute. They've been using the Sentinel satellites along with other observation systems to monitor the Greek islands since 2015, and it's helped them spot subtle changes in the caldera that could hint at what's happening beneath the surface. For instance, in 2012, they noticed the ground moving. In fact, the islands themselves were slowly drifting upwards toward the surface like a leaky air mattress. Between 2015 and 2021, the western section of the caldera inflated by about 2 meters, and the eastern section deflated by about 1 meter. Then in 2021, things started to change again. The western side started to deflate, and the eastern side began to inflate. There are a lot of factors that could cause these changes, such as the movement of tectonic plates or the weight of water that's being added to the caldera. But they all paint a picture of an underwater volcano that's full of surprises. In 2022, scientists used these observations to develop a 3D model of the volcano to get a better understanding of what might happen during the next eruption. The trouble is predicting exactly when that will happen. Scientists are looking for signs that the magma chamber under the caldera is filling up again, because once it reaches a critical point, the pressure could push its way to the surface. One team is drilling into the seafloor near the caldera to collect samples of magma. By studying its chemistry, they hope to find out if it's on its way up or staying put deep underground. Another team is exploring the underwater volcano itself using remote-controlled submarines. They're mapping its shape, taking samples and measuring gases that come bubbling out of the depths. Meanwhile, yet another team is creating a computer model to simulate past, present, and future eruptions. Each of these approaches helps scientists build a bigger picture of the volcano and how it interacts with its surroundings. And by putting all of that information together, they hope to figure out if and when the volcano might blow. It won't be easy though. For one thing, the deeper something is under the water, the harder it is to study. Plus, scientists can't just set up shop on an island and wait for the inevitable eruption. There are a few small towns located near the volcano, including a popular tourist spot called Fira. If the volcano erupts again, it could send ash and pumice raining down on those towns, forcing thousands of people to evacuate. So, instead, scientists are setting up shop on land far away from the volcano and using cutting-edge tech to peer into the deep waters. They've got high-tech ships equipped with sonar, which use sound waves to map objects underwater. And they're using unmanned submersibles that are remotely operated from miles away. These robots are equipped with cameras and other instruments that can take samples and measurements without anyone on board. And once the robots have collected all their data, they can be recovered without having to send a human crew into harm's way. It's risky work, but a necessary one. The thing is, if they're successful, their findings could help keep people safe beyond the shores of Greece. That's because there are volcanoes like this all over the world. And many of them are situated in areas with lots of people nearby. Yellowstone National Park, for example, sits on top of a supervolcano. If that thing erupts, it will destroy the park and everything for hundreds of kilometers around it. In fact, its last eruption was so violent that it left behind a lake of molten rock nearly 50 kilometers wide. That's about the size of Los Angeles. But Yellowstone has nothing on Lake Toba in Indonesia. Its supervolcanic eruption about 74,000 years ago blasted so much ash and gas into the atmosphere that it blocked out the sun. For years, temperatures around the world dropped as much as 5 degrees Celsius and ice ages followed in some regions. Scientists still debate how much it changed human history, but most agree that it drastically reduced the size of the human gene pool. That's why scientists are so eager to understand what's going on at the Kolumbo volcano and what might happen if it blows. Even though it's nowhere near any major population centers, its eruption could affect ocean currents and weather patterns around the globe. And if they can't predict when it will erupt, they also want to know how quickly people need to evacuate the nearby islands. Right now, it seems like a once-in-a-millennium kind of project. But the researchers involved say that their findings will help scientists around the world understand and monitor their own volcanoes. It's not a matter of if these underwater giants will erupt again, it's when. And the more we learn about them, the better prepared we can be. Thanks for watching this episode. We'd like to thank our supporters for helping us explore the world around us and bring cool science stuff to the whole internet. And you can help us keep making good science videos too. You can join our supporters and get fun perks like submitting a minion to be put in one of our videos.